Hello, hello, hello. Well, today is going to be our last day for assignment 8. We're going to be doing some more substitution method for solving systems of equations. So I'm going to get my timer up, wait for some people to join in on stream, and we'll get started. Meanwhile, I'm answering some email from students and getting messages from other teachers. Very exciting, I know. Boom, boom, boom. Morning, gentlemen. Let's see. I've been asked to recreate one that's similar to a question on assignment 8. Yeah, I guess we'll start there. Uh, 5.5 minutes, just enough time to make sure all your beds are made. Hey, it's Chris. Good to see you, man. Just updating some grades from late work. Mhm. 2 minutes, get your paper and pencil ready. Okay, we're giving everybody 1 more minute to log in and join us. Otherwise, they're gonna have to watch it on the replay. And here comes our friendly siren. Okay, it's time to start, but I've got a request from someone that I'm trying to handle, so I'm sorry for making you guys wait. Thank you for being patient. 1 second. Okay. I'll check back in on teachers and emails and stuff later. You guys have been patient and waiting, so we're going to go ahead and get rolling. So today, what we're doing is we're talking about, and again, we've been talking about this all week, that is solving systems of equations using the substitution method. And just like all week, I'm going to start with a quick demonstration of what it is we are talking about. So when you have a coordinate plane, you're typically going to start off with a y-axis and an x-axis. And we'll call this a system. Okay? That system is going to include multiple lines. So here's like line A going through the system. And here's line B going through the system. Well, line A and B might just meet. They don't always meet, because if they were parallel, they would never cross. And if they were the exact same line, they would cross all the time. But most of the time, they cross once. And what we call that is the solution to the system. Okay, so the solution is that one spot where the two lines cross. Now, if we were given a picture like this, it'd be easy. We'd say, hey, they cross right there. I see it. And you could label it with an x and y value. So you can just go ahead and label it with the x and y value and be done if they gave you the picture, but they don't always do that. So what we're practicing this week is how you dig up this xy value if they only gave you equations. That's what we're doing. So let me grab us our practice problems and we're going to get rolling. I'm hoping I don't double up on problems that have already worked this week, but it's a possibility. Okay, so paper and pencil at that ready. Let me go ahead and put the words practice problems on screen so no one thinks these are the actual assignment problems. Actually, we're going to start with, okay, a request. Okay, so one of your problems for assignment 8, I'm going to have to make one up real quick that is really similar. Unless I can find one that's really similar. Hang on. 1 second. Okay, I don't see any on this sheet that are really similar to the one that was requested, so I'm going to kind of have to engineer one real quick. Okay, so let's say let's say 3x plus ay equals and x equals -5y. Now give me 1 second. I'm gonna have to come up with this number real quick so that it actually works. Making up problems can be a real pain, but it's good exercise. Okay. I made this one up on the fly, but I'm pretty sure it should work. And this is very similar to one of your problems on assignment 8 that was requested. Yeah, Tate, that's actually what I'm doing right now. So this should be really similar. I had to engineer it, so I'm hoping I didn't do something up, but let's just try this one. Okay. So here's our system. What that means is that these two equations are they represent two different lines that go through the same graph, and we want to find the xy value where they crisscross. So here's what we're going to do. Since we know that x is equal to this stuff, -5y, we can take this and replace or substitute it in for the x in the other sentence. So what we'll do is we'll rewrite this guy right here as 3, but instead of putting an x, we'll put this up. So 3 times -5y. And the rest of it stays the same, plus 8y equals 14. So now we'll go ahead and solve this thing. Since it only has one variable, now we can solve. See, the problem with these other two is you can't solve when they have two variables, but now we only have one variable, so it is possible. So 3 times this stuff, 3 times -5y, that'd be -15y. And I still have this plus 8y equals 14. I still have all that. Well, -15y plus 8y, that's 7y, combining like terms. So 7y equals 14. -15 plus 8y, that's just integer rules. And now what we can do is we can divide both sides by 7. Because when we do that, 7 divided by 7 is equal to 1. So that's just 1y. So we'll end up with 1y equals 14 divided by 7 is 2. So y is equal to 2. So there's part of our answer. Remember, our goal is to find an xy value. So there's part of it. Now, to get the rest of it, what we'll do is we'll take that value, y equals 2, and we're going to jam it in right here in this other sentence, because x is equal to -5 times y, but instead of y, we'll just go ahead and use this 2. So x is equal to -5 times 2, which means that x is equal to -10. So our answer would be they cross at -10, 2. That's where the two lines intersect. That's where they crisscross. That's the solution. Yeah, Tate, that's exactly how that one would go. Thanks for the question. Okay. So what are the things we did on that problem? Math practice things, where are you? Let's talk about what we did on that problem. Okay. We made sense of the problem and we persevered in solving it. True. I had to use my abstract reasoning when I was canceling stuff out to get y equals 2. True. I was very precise with my numbers. I'm stretching the word tools here. I like to think that my structure of equations and stacking everything and keeping things nice and tidy is a tool, but that's a bit of a stretch. All the replacing, like whenever we do substitution and proving things come out equal, that's really, I think, constructing a good viable argument. But yeah. And of course, since we've been doing these all week, we're definitely using repeated reasoning skills. I was like, yeah, if it worked last time, it should work this time. Okay, so here we go. You need to see this. I'm reading chat. You need to see the second part of question 3. What do you mean? You mean the same one from assignment 8? Okay, so which variable did you solve for? Like what did you get so far in problem number 3? Did you get y equals something? If you're watching and listening, I've got questions about assignment 8, number 3. Yeah, but that was already given to you. Okay, hang on. Let me put this on screen for those of you that are wondering what we're talking about. Now, I don't want to give away an answer, so we're going to be really careful about what we all say, but it starts off with 2x plus 7y is equal to 3. And then it also gives you x equals negative 4y. Like that is problem number 3. Oh, you couldn't see the question? Oh, well, there it is. Yeah, number 3. I don't know why. Did anyone else have a problem seeing the bottom half of number 3? Seems odd. I mean, I could pull up the video. Now I'm worried that for some reason someone's not going to be able to see it. Oh, you didn't get it down in time. Well, why didn't you go watch the video on YouTube, silly? Okay, well then I'm not so worried. Yeah, okay. I will admit I cut off the stream, and I did think about that. So yesterday when I finished posting the questions for assignment 8, numbers 1, 2, and 3, I said see you later everybody and stopped the stream and then immediately put it on YouTube. But for the 4 or 5 people that were actually watching, they probably did not have enough time to write everything down. So I guess I was just assuming they'd go click to the end of the YouTube video, but oh well. Okay. So let's get a new problem for everyone that is sitting here waiting with paper and pencil and bated breath. Let's start with a pretty simple one. And I might have done this one earlier in the week, but that's all right. All right, try this one, guys. Okay. So we've got a system here. That means that these two functions, these two lines, exist in the same graph. So what we want to do is replace or substitute a value in one sentence using the other sentence's information. So you might notice that in this second equation, we've got y equals stuff, which is great. That's already done for us. So what we're going to do is take this stuff that y is equal to and substitute it in the top sentence for their y. See, we would love to solve for a variable here, but we can't because there's two different variables in the same sentence, but that changes after we do the substitution. So let's see what this sentence would become. So it starts off as 2x minus 3y equals -1, but now it's going to be 2x minus 3, but instead of a y, we're going to substitute in this stuff that y is equal to. So we'll put a parentheses and do x minus 1. So 2x minus 3 parentheses x minus 1 end parentheses equals -1. No, Chris, you're going to get the questions 4, 5, and 6 at the end of this video, and that'll finish the assignment. Yep, you're going to get the last 3 questions at the end of this stream. So we're just going to do a few practice problems first for people that need to see the practice. Okay, so what do we do? What do we do? What do we do? All right, so now the next thing I'm going to do, oh, I'm not even there yet. People are already giving me answers to check. Here we go. So I've got to take this -3 and multiply it by both terms on the inside of this binomial. So it's called the distributive property. So I get 2x. Now -3 times x would be -3x. -3 times -1 would be +3. Those are our integer rules. Negative times negative makes positive. This is all still equal to -1. So now I can combine like terms. 2x minus 3x. 2 of anything minus 3 of the same thing will be -1 of that thing. So it'll be -1x. And I still have +3 equals -1. So now I can subtract 3 from both sides. 3 minus 3 is going to be a 0. That's why I did that. That's abstract reasoning. What I mean by that is our main 2 abstract rules say that anything being combined with its opposite is equal to 0, and anything divided by itself is equal to 1. So those are our 2 main abstract rules we're going to be using today. So what do we end up with? Let's see. So we'll end up with -1x is equal to -1 minus 3 would be -4. And then our next abstract rule, we'll go ahead and divide both sides by -1. And like I just said, anything divided by itself is equal to 1. So what we'll end up with is 1x is equal to, now -4 divided by -1 is +4. Okay, so there it is. Now we've got half our answer now, because now remember what we're looking for is the place they crisscross, and part of that is an x value, but also part of it's a y value. So to get our y value, you'll remember we had this sentence up here that says y equals x minus 1. So what we're going to do is we're going to take, let me grab a different color. So what we're going to do is we're going to take this x value, x equals 4, and we're going to jam it right here. And we could do either one, but this sentence looks easier, into y equals x minus 1. So if y equals x minus 1, that means that y would equal 4 minus 1. Another substitution. And that means that y would be equal to 3. And that is how you solve using the substitution method. So our final answer, I guess if you wanted to write it as a coordinate, would be 4, 3, like this. Yeah, okay. Now the reason that one was so basic is that in the system, it told us that y equals stuff. It won't always do that. Sometimes you got to do a little extra work to get it there, to get started. So let's try one that's more like that. There's a good one. Okay. Okay, take a look at this one. This is not as simple as the last one we just did. In this system, neither one of the two sentences says X equals stuff or Y equals stuff. So what you and I have to do is figure out how we can change one of these two number sentences into being an X equals stuff or Y equals stuff. So which one of these looks easier to turn into either an X equals stuff or a Y equals stuff? Anyone in chat have an opinion of the top sentence or the bottom sentence? Which one looks like it'd be easier to turn into X equals stuff or Y equals stuff? I've got one answer I like. Anybody else want to chime in? Well, I think we could do it with both. I think that just because I'm lazy, I want to go the easy route. And I think this bottom one would be much easier to change into X equals stuff. Like notice it just says X minus 2Y is equal to 11. Well, if we just add 2Y to both sides, and I know they won't mix, but that's fine. I just want to get it over there. What we end up with is X. These cancel out. Thanks to our abstract rule, anything combined with its opposite makes 0. So what we end up with is that X equals 2Y plus 11. And that's what we were hoping for. So now we can use this to help out with our substitution because now we have X equals stuff. So what we're going to do is we're going to jam this value, this stuff that X is equal to in right here for that X. Because now we know X is equal to 2Y plus 11. So here we go. Let's try that. So it would be negative 7X. That'd be negative 7 times X. But we know that X is equal to this stuff. So that's going to be 2Y plus 11. So negative 7X, which is this stuff, minus 2Y equals negative 13. I've been tinkering around with an idea about that, Tate. I think the goal should be for everyone to still be done today. I think that needs to be the goal. Whether or not I actually come down with a hammer and say, you weren't done by 3, that's kind of up to me. But I want everyone's goal to be done today. Let's see. Okay, so now we do the distributive property. We've got to multiply this negative 7 by both the 2Y and the 11. So that would be negative 14Y. Negative 7 times 11 would be negative 77. And we still have this minus 2Y equals negative 13. We still have all that. We haven't messed with it. Combining like terms, I'm noticing some things we can already put together because I have negative 14Y and a negative 2Y on the same side of the equation. Well, negative 14Y minus 2Y would be negative 16Y. And then I'm going to go ahead and do the inverse operation now. I'm going to go ahead and add 77 to both sides. because these will cancel because they are opposites. That's my abstract rule again. And what do we end up with? So let's see. So I've got 16, negative 16y equals negative 13 plus 77. So that's the same as 77 minus 13. So 77 minus 10 would be 67, minus 3 would be 64. So now I can divide both sides by negative 16. Again, just abusing our abstract rules. Because anything divided by itself is equal to 1. And whatever I do to one side, I have to do the other side. Just because it's an equation, we have to stay balanced. So what do we end up with? We end up with y equals 64 divided by a negative 16, positive divided by negative, so I have a negative answer, and I believe that would be 4. So y is equal to negative 4. Now, once we have that, we can take that, and remember, we had a sentence up here we had engineered where it said x equals stuff. Well, now what we can do is we can take this value of y, the negative 4, and we can plug it in for this y right here and figure out what x is equal to. So that would be something like this. X equals, and it would be 2y plus 11. So it'd be 2 times y. But in this case, we know that y is equal to negative 4. So x equals 2y plus 11. X equals 2y plus 11, where y is equal to negative 4. Okay, we're good. So that means that x is going to be equal to 2 times negative 4 is negative 8 plus 11. Therefore, our x value, negative 8 plus 11, is positive 3. So apparently these two lines are going to crisscross at 3, negative 4. Those are our x and y values. There it is. Okay. I guess I'll leave it up to chat. We can do another practice problem, and then we can post the questions, or I can go ahead and put the questions for assignment 8 on the screen right now. That'd be questions 4, 5, and 6. If Chad doesn't vote, I'm going to do one more practice problem because I'll vote for all the people on YouTube that want to see more. Okay, so here we go. All right, I'm going to put a problem on the screen, and then I'm going to answer a remind question from a parent. So everybody on screen and at home, I encourage you, if you're on YouTube, pause the video once I post this question and see if you can get your work started, and then hit play and see if our scrapbook looks the same. All right. Everyone try this one while I check out this remind announcement. Remind response from a parent. 1 second. Okay, so everyone has had a genuine head start on me, but let's see what my scrapbook looks like, and let's see if ours looks the same in the end. So here's our system. I noticed they didn't give me an x equals stuff or y equals stuff, but I'm noticing this bottom section is pretty easy to manipulate. So it starts off with a negative 5x plus y, negative 5x plus y equals 19. So with a really, really quick abstract, if I just add 5x to both sides, what I'll end up with is y equals 5x plus 19, because these two things are opposites of each other and they cancel each other out. So now what I can do is rewrite this equation, making sure that y is equal to this stuff. And I'm going to put it in right there. So that'd be negative 3x minus 8y, but the 8y in this case is going to be 8 times 5x plus 19. Equals 20. So now I'm going to do the distributive property. This negative 8 needs to get multiplied by both the 5x and the 19. So I'm still going to have this negative 3x. So negative 8 times 5x, that'd be minus 40x. It's negative 8 times 19. Ugh. Negative 80. Negative 72. So we negative 152, I believe. Well, negative 8 times 20. I feel like I'm doing a number talk. Negative 8 times 20 would be negative 160. And I'm 8 short of that. So negative 152. Yeah, I think that's right. And all equal to 20. I feel like double checking this. Okay, so it was 19. Okay, so negative 5x. Bounce it over. So it'll be 5x plus 19. Yep. It goes in there. Yeah, so far, yeah, this is what it's looking like. Okay. So what next? Okay, combine like terms. I'm seeing that there's a negative 3x and a negative 40x, and they can go together. So that would make negative 43x. And I'm going to go ahead and do my abstract rule now. I'm going to go ahead and add 152 to both sides. So I'm going to have negative 43x is equal to 162. Thanks to the fact that these two are going to make a 0 out of themselves. Okay, so now I guess I'm hoping that 43 goes into 162 evenly. Let's see, 43 times, I don't know, like 4 maybe? Oh, wait, this would be 172. 172, Mr. Math, sir. Now that makes more sense, because now, yeah, that'd be times 4. So when I divide both sides by negative 43, and this would make a 1. Anything divided by itself is equal to 1. So I'm going to end up with x equals, so 172 divided by negative 43. I'm pretty sure that's going to be negative 4. Because 4 times 40 is 160, and 4 times 3 is 12. So 160 and 12 makes 172. Positive divided by negative is a negative answer. Yep. So x in this case would be equal to negative 4. Now, once I have that information, what I'm going to do is I'm going to take this value for negative 4 and jam it in right here. because y, we stated this earlier, that y is equal to this stuff. That means that y equals 5x plus 19. Well, 5x, where x is equal to -4 plus 19. Okay, which means that y is equal to 5 times -4 is -20 plus 19, which means that y is equal to -20 plus 19 is -1. So apparently our coordinate for where we place these two lines crisscross is at -4, -1. Okay, so there are our demonstrations for the day. By all means, pause, rewind, rewatch, check your work, and watch the replay on YouTube. But here come your actual problems for assignment 8. I'm going to label them so that no one is going to be confused, especially about what class this is for. Okay, so 8th grade math. Okay, so no one can be confused about who this is for. Check. Here we go. I'll make these easier to see in just a second. You guys let me know if your pictures on the screen are covering them up. And there they are. Okay. So for the sake of everyone that is actually here, I'm going to leave these up for a few minutes. I'm going to go get some tea. And then I will conclude, unless you guys have any questions, last minute like. And I guess I'll do the same as I did before, just as a little tip for anyone that is watching. The way I would start these problems, if you'll notice that x is equal to this stuff, well, you could probably substitute it in very easily right there for that x. You'll notice that y is equal to this stuff, so you can substitute it in for this y right here and get yourself started. And since y is equal to this stuff, you can substitute it in for this y and get yourself started. Okay, so there's my hint. I'm going to go get myself a drink, and then when I come back, you'll have had enough time to write these down. And if you didn't write them down in time, they will be on YouTube shortly thereafter. Okay.
Yo, Tate, unmute yourself.
What up, Chris?
What up, man? What you been doing, bro?
Nothing much.
I feel you, man. Dang, bro, we gotta do this work, man. This stuff, that ain't that hard, to be for real.
I need to get Braden to do it for me. I don't even know
Hey,
about it.
hey, man, do it for me. Some I don't know. Wait, what's your? Hey, email me on Gmail. Text me on Gmail
Alright.
and or something like that. Wait, do you got wait? Do that? Never mind. Yeah. Yeah, just email me on Gmail whenever we get done with this on something like that. Wait, who is that? That beasting dude.
That's Don Quarius.
Oh, that my boy Don Aquarius, man. How you been, man? I'm texting the Misha right now.
Uh-oh.
Bro, heck nah. I'm talking about for the work. So stop playing. Got a whole girlfriend. My girlfriend stay in Silicaga.
Mm-hmm.
Hey, bro, I be over there where you stay at a lot.
You do not be over here. I be out all the time. You do not be in this neighborhood.
I promise you I do. I be over there like over there. You stay over there behind Dairy Queen, right?
Yeah.
Yeah, I be over there.
I'm back. Any questions? Okay, hang on. I'm reading chat. Yeah, Tate, you got that one right. No problem, man. Way to persevere. Way to get through it. Okay. Well, I'm gonna close down the video, post it on YouTube. So if you need to go back and rewatch or check anything, it'll be there for you. Take care of yourselves. Take care of your families. Make your beds. I'll see you guys next time.